Hey guys, it's Miss Rainey. Today we are continuing with chemical nomenclature and reactions, and today we're looking at writing formulas, writing chemical formulas. I hope you're excited. I'm excited. Let's get started. All right, so when we are writing chemical formulas, we are looking at the word or the name and we're writing the chemical from that. If either of the words are names of polyatomic ions, we're going to write down the formula and the charge for those ions. If not, that means we have a single element and then we're just going to write down its formula and charge. So we're looking for polyatomic ions or we're looking for single elements. All ionic compounds are neutral, so all charges must add up to 0. So let me say that and let's get that here. There it is. All charges must add up to 0. So to accomplish this, we're going to add subscripts to make enough of each ion so that the charges cancel. Let's try one. All right, we're given the chemical aluminum oxide. So I see the word aluminum and I know that that's a single element, so I'm going to write down its formula and charge. But I'm actually going to write down the charge over here by where the word is because the final chemical compound should not have a charge in it. So I'm going to write it off to the left just to get it out of my space. Then we have oxide. So oxide is not a polyatomic element. Remember, polyatomic ion. Remember the "ide" means the ending of a single element. So oxide is just plain oxygen with the charge of -2. So now we're going to add subscripts to make enough of each ion so that the charges cancel. So I've got a -2 for the oxygen. If I multiply that by 3, that gives me -6. And I've got a +3 for the aluminum, so if I multiply that by 2, that gives me +6, so that I'll have the charges canceling out. Which means that I'm going to need 2 aluminums and 3 oxygens, Al2O3. And by writing that charge and that scratch work off to the left, my final chemical formula looks pretty and nice, Al2O3. So if we try it again, I see magnesium. Magnesium is just a single element. That is Mg, and its charge is +2. Then I have chromate. Chromate is a polyatomic ion. It is CrO4, and its charge is -2. And these charges are already equal, like they're already equal and opposite. They already cancel out, which means MgCrO4 is it. I don't have to add anything else to it. All right, so let's make it a little bit more complicated. Let's say you need multiple of a polyatomic ion. In that case, you are going to add parentheses before you get to the subscript when you're trying to make multiple. So for example, if we had ammonium sulfide, ammonium is a polyatomic ion with the chemical formula NH4 and the charge of +1. And sulfide, since it ends in IDE, tells me that it's the element sulfur with a charge of -2. So in order to balance that out, I would need 2 of these +1s so I can get +2 to balance the -2. But if I were to just put a 2 down there, so, and let me see if I can write it a different way. If I were to have NH4 2s, then I have 42 hydrogens and only 1 nitrogen, which is not what we're looking for. So I'm going to add parentheses around the polyatomic ion before I get to the 2. This will be seen more commonly in something like, well, I guess it would be weird more commonly in something like magnesium hydroxide. People a lot of times forget that subscript after hydroxide because they think it's just a single O and a single H, but we do need 2 of the H's and 2 of the O's. If we have a Roman numeral, when you're looking through, you see a Roman numeral, that's the oxidation number or charge for that particular element. It is not how many of the element. So, for example, if I were to have something like iron 3 permanganate, iron 3 means you have iron with a charge of +3. And then permanganate is MnO4 with a charge of -1. So now I'm going to need 3 of these -1s to balance out the +3 charge here. So I'll have a 3 down at the bottom after the parentheses. And then if there's a number prefixes like di or tri or tetra before either element, then there's no need to cancel charges. If you have the number prefixes, you don't have to cancel the charges. You just follow the number prefixes. So if we have dinitrogen, di means 2, so there's 2 nitrogens, N2. Pent means 5, so there's 5 oxygens, O5. There's no canceling charges, you're just writing exactly what it is. All right, so now we're going to look at writing formulas for acids. If the compound is an acid, and you're going to know it's an acid because it will have the word acid in the formula, then we're going to look at the root to determine the main ion and the prefixes and suffixes to determine the number of oxygen atoms. So let's see, we've got hydrosulfuric acid. When we see that word acid, we know that it will start with the element H. Anything that has acid will always start with H. That's the feature of acids. So then we're going to look at the prefixes and suffixes and the root to determine the rest. So this one is a hydro with a stem and an ic. Hydro-ic means binary, which means there's only 2 elements total, in this case, hydrogen and sulfur. You still have to balance the charges. So the hydrogen has a charge of +1, and sulfur, if we look on the periodic table, has a charge of -2, which means we're going to need 2 of these +1s to balance the charge, so that'll be H2S. Then we have carbonic acid, and so that starts with H because it's an acid. And now we've got carbon as my stem, ic. An ic acid comes from an 8 ion. I ate something icky. An ic acid comes from an 8 ion. 8 ic. I might, oh, hold on, let's try that again. I might grow humongous. So we've got ite and us. So anyway, carbonic means carbonate. Carbonate has the chemical formula CO3 with a -2 charge. Hydrogen is H with a +1 charge, which means we'll need 2 hydrogens to balance the charge, so H2CO3. All right, then we have hypochlorous acid, us. I might grow humongous, so I'm looking for chlorite, but in this case it will be hypochlorite. Hypochlorite has the chemical formula ClO with a -1 charge. You can look that up on your polyatomic ion list. You will be looking up hypochlorite. ClO with a -1 charge. We still have hydrogen with a +1 charge, and since those charges cancel out, then HClO is just it, and that's all we have to do. So let's practice what we've learned. You've got these formulas. I want you to pause the video right now and then work through and try to find the compounds, the formulas for each one of these compounds. Once you've got them, then you can unpause the video and check your answers. Pause your video now. All right, so hopefully you paused your video. Now I'm going to go through the answers and you can check and see how you did. We have ammonium thiocyanate. So ammonium is NH4 plus 1. And then thiocyanate, that will be on your polyatomic ion list. You just have to look it up. That is SCN minus 1. Since it's a +1 -1, then the charges automatically cancel. So we just have NH4SCN. Now vanadium. Vanadium is V, And then the V here is not telling you the chemical symbol for vanadium. It's telling you the Roman numeral 5 for the charge on vanadium. That's vanadium 5 fluoride. Fluoride is just F with a -1 charge. So in order to balance it out, I'm going to need 5 of these -1s to balance with my +5. So I have VF5. Next, we've got silver fluoride. Silver is Ag with a +1 charge. Fluoride is F with a -1 charge. Those charges automatically cancel, +1 -1, so we're done at AgF. Next, we have nitrous acid. Ooh, I see the word acid. Acid will start with hydrogen. I might grow humongous, so nitrous comes from nitrite. Nitrite is NO2. The charge on NO2 is -1. The charge on hydrogen is +1. Those charges cancel out, +1, -1, so we're done with HNO2. Now we have xenon hexafluoride. Xenon is Xe, and that's a noble gas, so that seems weird about looking for the charges. But then I see hexafluoride. Hexa is the prefix for 6, telling me that this is covalent, and I do not have to cancel the charges. I just have to write down what we see. So if fluoride is F and it's hexafluoride, that'll be F6, and that's it. And last but not least, I've got copper 1. So that's Cu with a +1 charge. And then sulfide, the I tells me it's the element sulfur, and it's -2. In order to balance those charges, I will need 2 of those copper 1s to get me a +2, so Cu2S. Now you've got 5 more to try. I want you to pause your video now, try these next 5, and then unpause when you're done to see how you did. Pause your video now. So hopefully you paused, and now you're ready. Let's look at the formulas for these. I've got aluminum acetate. Aluminum is not ammonium, it's the element aluminum, that's Al, with a charge of +3. Acetate is the polyatomic ion, C2H3O2, with a charge of -1. I will need 3 acetates to balance out the charge from the aluminum, but we can't just write a 3 because then there's 23 oxygens, so instead we'll C2H3O2 parentheses and then a 3. Now we have beryllium hydroxide. Beryllium is Be, and the charge is +2. Hydroxide is OH, and the charge is -1. I'm going to need 2 of those -1s to give me -2. But again, don't just write a 2 there, because that's 2 hydrogens, but just 1 oxygen. We need parentheses around the hydroxide, so we have 2 hydrogens and 2 oxygens. Next, we have diiodine pentoxide. So that means this is covalent, and I don't have to balance charges. I'm just going to write what's there. 2 iodines, I2. 5 oxygens, O5. Done, and move on. Now I have hydroiodic acid. Since it's acid, that starts with H, and H is a +1. Since we have hydroic, that means it's binary. There's only 2 elements total, hydrogen and iodine. The charge for iodine is -1, so those charges balance. So hydroiodic acid says high. Now we've got phosphorus trichloride. Phosphorus is P. And if we're looking at the charge, sometimes it's hard to tell, but I see a trichloride, which means I don't care about the charge. There are 3 chlorines. This is covalent, PCl3. And now I have potassium, which is K plus +1. Bromide, which is bromine, Br minus. Those charges balance. Potassium bromide is just KBr. All right, our final naming and writing goes together, and we're going to look at the hydrates. Hydrates are ionic compounds that trap water within their structures. Both the name and the chemical formula specify how much water is trapped. So we're going to look how much water using the name or the chemical formula. Both of them have that there. So we're going to write the formula for the ionic compound using the same rules we learned earlier. And then what's new is we're going to add a dot and the correct number of waters taken from the prefix. So for example, sodium sulfate has the chemical formula Na2SO4. But then it is deca. Oh, that was a bad highlight color. Let's try again. Deca, that means 10. And then hydrate, that means water. So the decahydrate means 10 waters, and then notice how there's this little dot in between. So I'm going to write the chemical formula for sodium sulfate and then a dot with 10 waters. So if I was going to go barium chloride dihydrate, my step number 1 is writing the chemical formula for barium chloride. Ba, which is +2, Cl, which is -1. I will need 2 of those chlorines to balance the charge. And then the dihydrate is going to add 2 waters, so dot 2 H2O. So for every 1 barium chloride molecule, 2 waters stick to it. If you're going the opposite direction and you're naming hydrates, we're going to write the name for the ionic compound using the same rules that we learned earlier. But now we're going to use number prefixes like mono, di, tri with the suffix hydrate to signify the number of water molecules within the structure. So if I was going to name this, the first thing I would name is FeCl3. Fe is iron, Cl is chlor, and we're going to end it with "ide" since it's a single element. Also, iron needs a Roman numeral, so we're going to have to figure out the Roman numeral for iron. And context clues tells me chlorine is -1, and there are 3 of them, which is a total of -3. So that means iron has to be +3 to balance it out. So that means my Roman numeral is the Roman numeral 3. That's iron 3 chloride here. The hydrate part of this is 6, so 6 is hexa. So we are just hexahydrate. So we have iron 3 chloride hexahydrate. All right, that is naming compounds, writing compounds, hydrates, acids, ionic, covalent. I hope you learned a lot. I know I sure had a lot of fun teaching you. I'll see you next time.